Smart House MimiSmart by the MimiSystems company. The Smart House MimiSmart System with distributed logic developed by MimiSystems with plug-and-play technology is simple. And now we will convince you of this by assembling and configuring the system before your eyes, almost from scratch. Set the statistics server, connected to the power supply, then to the Ethernet. The server appears on the service information screen. Using the computer, we enter the program MimiSetup. The program has the following tabs. Server configuration, to create configuration backups. Scripts editor, allows you to add and edit scripts. Keys editor, sets access for users. Update tab, allows you to update software. The XML editor tab displays all devices in the system on the computer screen in the form of a tree. Connect the gateway. We need it to convert the CAN package to Ethernet. As the gateway is connected, the XML editor tab displays recently connected devices. Here we can see the infrared receiver and temperature sensor appear, as these are built into the gateway. For easy installation, we use a splitter to connect the CM9 control module. Connect the following items. 2-channel load control module and single-channel dimmer. As we connect these elements, they are displayed on the screen of a tablet and in XML editor tab. At this stage, we can control the lights and adjust their brightness. Now we connect some sensors. Their connection is immediately displayed on the tablet screen and in the setup section of the XML editor tab. As you can see, the sensors are already operational. Connect the buttons adapter. In this system, there are 3 switches. Turn on engineering mode in settings on the touchscreen. Long hold. Press the button, it is now defined. Click link, then apply. Now we can control the lamp using both the switch and with the help of the interface. In the same way, we can bind the switch with the dimmer, turning on and off with a short press. A long press enables to change the brightness smoothly. The buttons of the switch have built-in lights. After we set the appropriate settings in the Mimi Setup panel, we can see a red LED when off and a green LED when on. To bind the lamp with the switch, go to the Mimi Setup panel, then Bind Buttons. If desired, you can remove the previous binding and bind a new switch. Select existing switch or use the Auto Learn system by pressing the button and bind switch. There are several basic types of lighting automation, by window or door opening, or by motion or lighting level. Connect the RGB control module, which has 4 channels. 3 of these are used to control the RGB strip, and another to control LED lighting. Connect this to the CM9 module using the splitter, and separately connect the power supply module. We can now see RGB and LED lighting in the interface. Now we can turn lights on and off, select color, manage color, and change the brightness of a backlight. The next item to connect is the gyro switch. This is a switch with 6 buttons. Configure the buttons binding with the RGB lighting. Long hold RGB lighting, press the button, it is now defined. Click link, then apply. Now we can see that a short press of a button either disables or enables the RGB lighting. A long hold changes its brightness. We now have infrared receivers in our system, which are part of the gateway and the infrared transmitter. We can now add and teach the remote control to control the TV. Press Add Remote Control. Choose Blank and type in the remote control name. After adding the remote control from the Mimi setup, we can see that a new tab appears in the interface. Select it and Teach Remote Control. Click on the title 4 times, select Infrared Receiver and Infrared Transmitter, and select the button. Send the signal from the remote control to the infrared receiver. Buttons become active and a corresponding command is recorded. Exit from the teaching mode. Now, if you press the button, you will send a command to the desired device. The Mimi setup panel allows you to use scripts written by the manufacturer in advance and scripts that will be created later. For example, in climate, choose one of the scripts that allow you to control the air conditioning. Next step, enter the air conditioner name and choose an infrared transmitter to control them. After setting up in the Mimi setup panel, we have a tab with the chosen conditioner. Now we can turn it on, select the desired temperature, its mode, and the shutter's direction. For protection against water leaks, we have the following system parts: valve, valve control module, and the leakage sensor with adapter. Connect these. Connect valve to the power supply, which appears in the interface in the Execute tab. The sensor will appear in the Sensors section. If the sensor detects a leak, we can see that the icon changes. By double-clicking, you can reset the information and choose to ignore a certain period of time, during which time the sensor will not react to moisture. Now we have connected the valve and leakage sensor, we combined them with each other. Select valve in the tab Add Leakage Sensors, choose Leakage Sensor and apply. Now if the leakage sensor detects moisture, the valve will close. Connect the 8-channel heating control module. Using the interface, you can specify not only the temperature that will be maintained constantly, but also the schedule of the heating system, by time of day and day of the week. Connect the multi-room system. This is a media application which outputs to the speakers. A multi-room tab appears in the interface. Here we can manage playlists, playback, volume, and scroll through the tracks. Connect the next item to the system, the web camera. Once connected, the tab Camera appears. Now we can control its position. Connect the GSM module. This performs 2 functions: voice or SMS notification of events and Smart House control via voice menu. In the list of scripts, select Scripts for GSM module. Add the script for checking balance. Once done, we can see the current balance on the screen of the tablet. The next item is a standard Mercury 206 electricity meter with an RS485 and RS485 adapter connected to it. This module transfers the meter readings data from the meter to the Smart House system. Set up a script to display its parameters in the interface. Specify the electricity meter's serial number. The Sensors tab in the interface section shows Electricity meter, where you can select the following parameters: the current meter reading, the voltage on the meter, power consumption, and frequency. Now we are going to add a pulse type water meter to our system. We connect it as a reed switch. We detect the number of closures as with a usual reed switch. To simulate the flow of water, we set the fan to expel air. As we apply power to the fan, we can see the meter counter moves. Now let's connect the smart intercom. The intercom signal can be transmitted to any device connected to the system. After connecting to the system, it is automatically configured. With the same principle, we can add scripts to the system that will send SMS based on the sensor readings and MMS from cameras. This is an example of a more complex script. Simulate the water leak.
Attention, water leakage was detected.
As we hear the sound notification and see how the valve overlaps, we receive a text message about this event. Distributed logic allows the system to operate even if some basic elements are missing. We will now demonstrate this. The system is configured and operating with buttons and tablet. Motion sensor automation is configured. Remove one of the main modules, Statistics Server. As you can see, the system is still working. Including motion sensor automation control and tablet control. Disable the gateway. One of its functions is to power peripherals. We are replacing the gateway with 2 batteries. Automation is still working, as well as local controls such as the buttons. There is no possibility of distance or remote control from the tablet, because there is no connection between the Smart House interface and Ethernet. However, locally, the entire system is functioning. Turn off the power to the CM9 module. Replace it with batteries. Now we cannot control the lighting with another CM9 module, but can still operate peripherals, including automation, with a single module. Even separating the system into functional blocks allows full operation of the system, providing there is an uninterrupted power supply on each of the disconnected blocks. We hope that we have shown that connection of our system isn't difficult and is reliable, functional, and easy to configure.